is our lesson on scientific notation, Advanced Math 7, Module 8. Scientific notation is used for really, really big numbers and really, really small numbers, which you will find in all kind of forms of science. If you were actually in class, we would do a little bit of discovery learning, but now I'll just report what will actually happen. We just showed that when you multiply 7.6 by 10, you get 760. So that multiplying by 10 is the same as just moving the decimal one place to the right. 28.63 times 1,000 is 28,630. And we can see that multiplying by 1,000 is the same as just moving this decimal 3 places to the right. Dividing by 10 is the same as moving the decimal one place back. And dividing by 1,000 is the same as moving this decimal 3 places back. And keep in mind that dividing by 10 is the same as multiplying by 1/10 or by multiplying by 10 to the negative 1. Because remember, these are equal. So when you have a negative exponent to a power of 10, it's like dividing, or you would move the decimal back to the left. The only way this lesson will work for you is if you press pause when it's time to work each problem, and then press play again when it's time to check your answer. So press pause as you try to write this number that is written in scientific notation. Try to write it in standard form, meaning just as a regular number. So in standard form, this actually equals 3,700,000. Since I'm multiplying by 10 6 times, I simply have to take this decimal and move it over 6 places to the right and fill in my empty spaces with 0. And of course, I'll put commas in the right place. But this also should make sense to you, because hopefully you know that 10 to the third is 1,000, 10 to the 6th is 1,000,000, 10 to the 9th is 1,000,000,000, and 10 to the 12th is 1,000,000,000,000. So this is a million. So if it was 3 times 1,000,000, that'd be 3,000,000. So 3.7 times 1,000,000 is 3.7 million. Press pause and try to work this one. Write it in standard form. So the answer is 912.3. I'm multiplying by 10 twice, which is the same as simply moving this decimal 2 places to the right. Go ahead and press pause to work the next one. So this time, since I'm multiplying by 10 to the negative 3, that's the same as dividing by 10 3 times. I would move this decimal 3 places to the left and fill in the empty spaces with 0, giving me this answer. Press pause to work this one. So for this one, I have to multiply by 10 to the negative 5th, which is the same as dividing by 10 5 times. So I have to move the decimal 5 places to the left. What decimal? The one that is here, because remember, this is the same as 235.0. Simply move this 5 places to the left, fill in the 2 empty spots with 0, and you have the correct solution. Before we go on to the next page, I want to point something out. These first 2 numbers are actually written in true scientific notation.
What?
These are written in kind of scientific notation, but not really.
What?
The thing that makes it true scientific notation is this first number has to be a value between 1 and 10. Notice these 2 numbers here are not between 1 and 10. The only reason why we do that is so that everybody who writes in scientific notation will have the same thing. For example, you don't want this to be 37 times 10 to the 5th, which equals that, but it's 2 different things. So they go with the rule, make sure this is between 1 and 10, so everybody will write the same thing.
You know what I'm talking
To
about.
make this really easy for you, to make sure this is between 1 and 10, you can only have one non-zero number in front of the decimal. One non-zero number in front of the decimal. So for this page, we're going to take these numbers written in standard form and write them in scientific notation. Press pause and give it a try. In scientific notation, this equals 3.28 times 10 to the 7th. Because I need to put my decimal here so that there's only one number in front of the decimal, so it's between 1 and 10. Notice this is between 1 and 10. But we know the decimal is actually here. That's where it is in the number. So to get it from where we're pretending it is to where it really is, we'd have to move it 7 places to the right, which is the same as multiplying by 10 7 times. Write this one in standard notation, press pause, and then come back. Here we go. It's 6.7 times 10 to the negative 4. I know I need to put the decimal right here so that I have a value between 1 and 10. So I'm pretending like the decimal is here, but it's really here. So I would have to go back 4 places to get it to where it really is. So it's like dividing by 10 4 times. Press pause and give it a try. This one was pretty easy. If you don't understand this, press pause and stare at it, and hopefully it will come to you. Press pause and do this one. So I know I have to put the decimal here so that my number is between 1 and 10. But I know that the decimal is really here. So to get it to where it really is, I would have to move this 9 places to the right. So I'm multiplying by 10 9 times. This also makes sense if you want to ignore these numbers right now. You can think of this as 2 billion. And remember, a billion is 10 to the 9th. Let's try number 5. Notice I wrote it like this. Putting the spaces behind a decimal every 3 places is the same as putting commas in front. It makes it easy to read. Press pause and come back. So here is my answer. I have to put my decimal here, so it's in scientific notation. But we know it's really over here. I would have to move this back 9 places. Another little trick for the ones that you know are going to be negative is watch this. The very first non-zero number behind the decimal is in the 1, 2, 3, 4, 5, 6, 7, 8, 9th place. Since this is in the 9th place, notice that matches this. Little help. These instructions say to write in scientific notation. Some people would say, well, it's already written in scientific notation, but it's not because this is not a number between 1 and 10. So what you want to do is you want to write a number that equals this number, but in actual scientific notation. Press pause and come back. And here we go. Here's the deal. This number actually equals this number with the decimal moved 8 units to the right. But now I have to put the decimal here. So to get it to where it really is over here, we'd have to move it 1 place plus the other 8. We'd have to move it 9 places to the right. Press pause and try this one. 3.67 times 10 to the 4th. I have to put my decimal here. Now keep in mind this actual number equals this decimal moved 5 places to the right. But I already moved the decimal to here in my new number. So I already moved it 1 of the 5 places. So I only have 4 more to go. Try this one. Let's see. I have to write it as 2.39 to be in true scientific notation. So let's see. This decimal is actually moved back 4 places to the left. But it looks like I already moved it 1 of those 4 places. So I only have 3 more to go, still to the left. Press pause and come on back. So here's my answer right here. The actual number has this decimal moved 7 places back to the left. But I have to put my decimal here. So it looks like to get it over here, I have to move it back 3 places and another 7. Therefore, this would be wrong. This would be to the negative 10. So it's actually 6.5 times 10 to the negative 10. Okay, here we go. Press pause and come. So it's 8.2 times 10 to the 9th. This should be pretty easy. We've talked about this before. Billion is actually 10 to the 9th. So 8.2 billion is 8.2 times 10 to the 9th. If you don't see it, this is what 8.2 billion looks like. Okay, ignore this. This is what 8 billion looks like, and the 2 is right behind here. This is 8.2 billion. At least now it is.
Come on, you can do it.
And then you simply have to convert this into scientific notation. Press pause and come back for this. So the answer is 3, or 3.0 times 10 to the negative 3. This is the way of writing 3 thousandths. To write in scientific notation, there it is. Okay, here's a good problem. We've got some values for m and for n. And we want you to figure out what n minus m equals. And we want you to write your answer in standard form. This might take you a couple of minutes, so go ahead, press pause, and come back when you're ready to check your awesome answer. And here we go. All I did was I wrote out the big number n in standard form. subtracted m, which is already in standard form, I got this number. So that would be my answer in standard form. If I had to write it in scientific notation, I would probably write 4.75 times 10 to the 6, because this is about 4 million, and I know 10 to the 6 is million. Well, yeah, that was my next question, and there it is. Okay. Now here's one. N is how many times bigger than M? You may have seen that little answer, but go ahead and figure out why it's that. Press pause and come on back. Now for this one, I think it was actually easier to write each thing in scientific notation. When you're trying to figure out how many times bigger, you will divide. So the big number divided by the little. And watch how easy this is. Since this is all multiplication, I can kind of split it up. 5 divided by 2.5 is 2. And then 10 to the 6 divided by 10 to the 5, I can just subtract my exponents and get 10 to the 1. So what does this equal? 20, the answer. Try to work this problem, press pause and come back. This problem should involve multiplication because each block weighs this amount, so I'm going to multiply 600 times the weight of each one. And since this is all multiplication, I can do it any order, any grouping. So I'm going to go ahead and multiply my 600 times my 5.9. I'm just going to do that in my head and get 3,540, and then times 10 to the negative 2. Now I have to write this in true scientific notation. So let's see. This is actually, this decimal moved back 2 places because of this, but I'm pretending like it's here, so I'd have to move it 1 place to the right to get it there. So this would be my answer in scientific notation, and actually I should add the word pounds because we need to have units. Okay, last problem. Go ahead and give it a shot. Press pause and come back when Bill and Eddie are ready. Welcome back. You've been missed. So this, hopefully you know, is a subtraction problem. So I wrote out both numbers in standard form. I did my subtraction. I had to do some borrowing, but that's okay. You've been doing that since 3rd grade. And this is my answer. So in standard form, it is that many miles. And then it says to write answers in both forms. So I will write this in scientific notation and get this answer right here. And again, that should have miles as the units. That's all we got for this scientific notation lesson. Goodbye. Live long and prosper.